Good morning, good afternoon, and good evening, everyone. My name is Nate. I also go by Hockey Boy Nate, and today we are going to be discussing still the threat for severe weather outbreaks heading into Friday and Saturday, as well as on Tuesday. I won't really get into what's happening after that because it's just too uncertain right now in regards to what can happen after. It's all kind of a domino effect that we really have to watch out for, but. One thing to note real quickly before I self-promote, well, I am self-promoting technically, we'll be live streaming on Friday. That will be tomorrow. So make sure you guys turn on notifications, and I'll also have a live stream set up to where you guys can actually go onto the page and all, and set notifications for that as well. So make sure you guys stay tuned to my live stream tomorrow. We will be covering the event on Friday, which does have a 5% chance for tornadoes. So please stay tuned for that. If you guys are new to my channel, please be sure to leave a like, subscribe, turn on notifications, share this with friends and family and on social media. I do videos like this every single morning, as well as do live streams for the events if they get bad. So, with that being said, let's get into the video. Day 1 outlook is right here, and nothing's to it. There's nothing really much to talk about here besides just general thunderstorms here in the general vicinity. If I switch my camera, you can see that, area near Miami has general thunderstorms, but nothing really too serious here. Day 2 outlook here. If I go backwards in time real quickly, here's the day 2 outlook, and a massive slight risk has been issued in some of these areas. The places that could be impacted include Houston, San Antonio, Dallas, Austin, Fort Worth, Oklahoma City is within this slight risk as well. Also areas like Shreveport, Jackson, Alexandria, Lake Charles, you guys could be impacted. So anywhere within this yellow right here is where you guys can see some severe weather. Honestly, I feel like there could be some areas that could be upgraded to an enhanced, especially around here in Wichita Falls, around the Triple Point, if thunderstorms do develop, but the uncertainty is too large right now for anyone to say for certain that could be possible. But I would not be surprised if an enhanced was issued around that area, or even around the dry line right here. But I honestly think that this area here near Wichita Falls is probably going to see an enhanced, mainly for hail. I don't really say tornadoes a whole lot. I think this is going to probably stay within the 5% vicinity, but it might go a bit higher. I'm kind of jumping the gun here because I should be showing you guys the visualette as to what each risk is going to be like. But we might as well get into that. Hail risk, massive, 15% extends. You also have your pesky hatched risk here. So on normal occasions, if you would, not include this hatched risk right here, you'd either have a 5 or a 15% chance, 5 indicated in brown, 15 indicated in yellow. So whatever chance you have, that's your probability of getting 1-inch size hail or larger within 25 miles of a point. If you add that hatched risk on, you get a significant chance for, a significant severe risk, a 10% chance or greater of seeing hailstones 2 inches or larger, and that can do damage. So if you live in any of these areas here in the significant risk, Dallas, Fort Worth area, Oklahoma City, all the way down to Austin and Waco, you guys really need to plan accordingly. I'd highly recommend bringing indoors your pets and valuables that may be outside, as well as moving your cars towards a sheltered area, because hailstones up to 2 inches could do damage, and that'll be that wouldn't be fun explaining that to the insurance agency as to why your car was damaged. But as I said, a significant severe risk here. The something that's pretty interesting that I wanted to mention here is that this significant severe covers 13,300,000 people. And so that's not a small feat, guys. That's a very large area that could see significant hail. So it's all the more reason to which we need to continue to get the word out, and we need to try and help people as much as possible. Winds 15% in 2 areas. There's this one over here in Oklahoma and the border of Texas because of the triple point and how there could be a QLCS that forms off of that. We'll get to that more when we get to simulated radar. And then we also have this 15% for the prefrontal convection that really just lingers all the way through into the morning of Saturday. But you still have that 15% chance for wind there. And so definitely something that people who are in these yellow areas need to continue to monitor that for 58-mile-per-hour winds or greater. That is the probability for you all. Last but not least, I hinted at the 5% chance for tornadoes. There it is. Places near Norman and Oklahoma City, down south to Fort Sill and Wichita Falls are in it. Also, areas near Dallas-Fort Worth towards Waco, Lufkin, Shreveport, Jackson, Alexandria. You guys are also in the 5%. This 5% down here, as I said, is for the prefrontal convection that starts from the afternoon on Friday, goes all the way through into the morning of Saturday. So this is definitely something that we're going to want to watch and monitor as this continues to unfold in front of us. A lot of activity that is planned here for this event. Let's get into the simulated radar here. This is in the morning right now here on Friday. Well, not right now, but this is in the morning on Friday, 7 o'clock in the morning, just to get the overall picture. A lot of scattered convection here for the most part, but not like really like all too strong convection. It's more or less just general thunderstorms. Now we zoom off towards the 1 o'clock hour here, or actually no, the 11 o'clock hour here for you guys. And at 11 o'clock, your scattered convection starts to build up a bit more. And once we start to get towards the noon hours, even into the 1 o'clock, 2 o'clock hours, storms really start to bubble up. And that's the prefrontal convection that I'm talking about. You have a lot of these thunderstorms that begin to develop, especially down here in eastern Texas. You know, eastern Texas is really going to be in the heart of these main risks. You know, and we'll talk about that further, even with the next severe weather outbreak that occurs on Tuesday. But, you know, this area of eastern Texas is really something that we need to watch out for the most part in regards to this this risk. But a lot of prefrontal convection still moves on through. We're at 5 o'clock hours all the way up to 8 o'clock. And you can see a lot of these storms are continuing to bubble up in the 5% area here from Texas all the way over to Mississippi. You also have some cells that are beginning to develop here in Oklahoma. And I want you guys to watch that real quickly as we head into the overnight hours. So this is 8 o'clock right now. 9 o'clock, right around Wichita Falls, there's some more cells. This is right around where the triple point would be, which is the could be the greatest area of where thunderstorms could develop if they were to, even if it was, even if it did have a limiting factor in the atmosphere. And that's usually universal for any sort of severe weather setup. If there's ever a triple point, there typically is some storms that form within there, and they tend to be the strongest or the most structurally sound within the event. So as we continue to move on through 9 o'clock, 10 o'clock, boom, you have your line of storms that form from Oklahoma down into Wichita Falls. You have your supercell that develops right within there. And as that continues to move on through, you can see that cell really starts to pick up and now turns into a QLCS, quasi-linear convective system. So you can see a lot of gusty winds here within this, and that could translate over overnight as well. I also wanted to talk about this area right here. This is around the midnight hours here in Central Daylight Time. A lot of thunderstorms that begin to develop. There's even a band of storms that actually form off of this. And so right around the 3 o'clock hours, you can see more thunderstorms. The more and more they develop, you can get these quick little spin-ups within the line, or even these just general, you know, scattered convection that is coming off of the Gulf of Mexico. And so as storm motion, well, not really storm motion, but as motion, general motion, lower level motion of these storms, the low level jet moves off to the north and east. If some of these storms could get rooted, they then could go a bit more to the east, northeast, and that could potentially throw a lot of people off, especially with how slow those storms will move and basically like ride along the line, and how it can continue to gain more and more energy as it continues to move overnight. But the thing about it is with these overnight events is that there isn't really a lot of energy because the sun's not out. There's not a lot of cape that sits around. And, you know, as most of you know, when it gets nighttime, it gets colder. So that's the good news for that in regards to the kinematics. But moving on through, we're going to zoom into the deep south here. And this actually is for the 5 o'clock hours here in the morning. You can see here's your QLCS that is starting to show up from Oklahoma and Arkansas. You also have another band of storms here, and this is the scattered convection I was talking about. You can get these quick little spin-ups here within the line that could potentially become tornadic, but you got to have them rooted, and you got to make sure that the mesocyclone actually develops in order for it to become tornadic. So that's something to keep in mind. But as that continues to move along into the early morning hours, into the sunrise hours, the first line starts to kind of decompose. The second line starts to really kind of take over. And so that is something that we'll continue to have to watch. And we'll talk about that more later on in the video for Saturday's risks. Dew points. A lot of moisture here. You can see indicated in these oranges, they're 60s to 70s. These yellows are actually a bit more of the 60s, but 70s for the most part here, right within this general vicinity in Texas. This right here, this line right here is really interesting to me, especially since whenever we see this, first off, we call this a dry line, and this can actually enhance thunderstorm development by moving on through. And that could also create a very large hail threat. That's the reason why the hatched risk for hail is out there, is because how hail is actually formed is dust particles are actually suspended into the atmosphere. And when you get a specific height in the sky, the precipitation, the rain that actually gets suspended that high turns into ice. But in order for it to turn into ice, you need dust particles. And so if you actually have dust particles in the air, you can actually have ice form around that a lot more effectively. And if you have a lot of dry air in that environment, then you can potentially get some very large hailstones. As I said, in upwards of 2 inches, maybe even larger in some spots. Would not be surprised based off of how dry the atmosphere is that high up. But definitely could see baseballs, definitely could see 3 inches. Yeah. I'd say 3 inches is a good max. I'm not saying that everywhere in that area is going to get 3-inch size hail. I'm just saying that some areas could. Some areas could get 3-inch size hail. But, the dry line is ever so prevalent. A lot of moisture. Checks out. Cape, for the most part, is going to be pretty interesting because we're going to be talking about 2 different things with Cape. Two different events within the same day with Cape. First things first, we're going to talk about the prefrontal convection that starts earlier on from the afternoon. And there's decent amounts of Cape here in northeastern Texas for it. Up into the 1,000 joules per kilogram range. Some up in upwards of almost 2,000 if you get further into the southeastern, maybe even east central parts of Texas. But this general vicinity right here, where this prefrontal convection could fire off. There is some decent amounts of Cape, but not too much Cape to where it can explode into massive supercells. But you could potentially see some tornadic development in here if they can actually get in and sink within this Cape and start to absorb it a bit more. But one thing I do also want to mention, which kind of leads into our next slide here, shows a lot of Cape here along the dry line. There is a lot of energy. And as that pushes on through to the time in which thunderstorms are expected to develop, we can see Cape numbers in upwards of 3,000 joules per kilogram, maybe even 3,800 joules per kilogram. 4,000 maybe pushing it a little bit, but it does get into that general vicinity of some of these dark reds, which actually start to lean towards that. So a lot of energy here, especially around this triple point. A good way to find a triple point here on Cape, and even dew points. If we go back to dew points, a good way to find triple point is when you have a dry line that suspends up like this and that it curls back And then you also have your warm front. Your warm front right here. Whenever it kind of curls and your warm front ejects on through, anywhere in between the warm front and the nose of the dry line right here, that's where you can get some thunderstorms that can begin to develop and could become rather strong. And so that's just something that I wanted to point out here real quickly. With this being in the triple point and how much energy is in here and how it's basically channeled into one specific area, that could bring some massive hail within areas near Wichita Falls. So definitely something we're going to have to watch as that continues to move on through. Here's the low-level jet here for this event. You can see some decently strong shear here at the lower levels, and upwards of 40 to maybe even 45 knots in some spots, but very much so localized. You can see how it cuts off right around here, and that's because this is actually the boundary that ejects on through here with our low pressure system. So if you were to go back to our dry line, or just imagine it, I've been drawing it over and over again, but it's right around the same area into which the dry line is. And so your low level jet really starts to kick up right in front of that dry line. And if you can get some storms that can form off from the outside of the triple point and move on into that shear, then you could potentially have some tornadic cells that form on later on in the evening. But the reason why I'm pretty concerned with this prefrontal convection is because you get some of these storms that actually form out in some of this enhanced low-level shear. And, you know, you'll see here with this next slide, the upper-level shear, it's pretty strong as well in some of these areas. You can see some in upwards of 70 knots, maybe even 75 knots, but that's kind of pushing it a little bit. So I'll say 60 to 70 knots here for the most part in this area. And if we go back to the slide here real quickly, we'll go to the, we'll draw an arrow as to the low-level shear and its general direction and where it's going. So we'll draw an arrow right here. Boom. And then we're going to go to our next slide here, which is the upper level jet, or mid-level jet, I should say. And we'll change that to red per se. And you can see how these start to cross over in some of these areas. And with this veering into the atmosphere, you can see some supercells that begin to develop within this. And, you know, even without using a sounding, that's a good way of telling as to where tornadic potential could be within, you know, just regular events. So something to keep in mind, that veering is there, and it is evident on the wind shear profile here, according to the NAM 3K. All right, let's take a look at some sounding. This is pretty interesting for the most part. But we're going to talk about 4 soundings that I took from this event. So right here, this is southeastern Oklahoma, northeastern Texas. This is the northern part of the prefrontal convection. You can see the hodograph is all right. You have some good veering, but you have some VB, veer back, here from the 1 to 3 kilometers here. It does actually create a nice little outflow here in regards to storm motion. So you could get some supercells that last for quite some time just by riding along and not being impacted by either its own outflow or its own storm, its own body of hail and mess that comes from whatever core it has. So I do anticipate that. It does seem to be a cyclic type based off of how it looks as a hodograph. But definitely something really interesting to say the least. There's a lot of streamwise vorticity here from the 0 to 1 kilometer shear, but from 1 to 3 kilometer, there's not at all. So it will look kind of decent at the surface. You know, you'll have your wall cloud, but you won't get like these classic mothership look to it. So just something that I wanted to point out with here. I'm not going to be using Cape a whole lot for this particular sounding because, as I said, it's going to be pretty low for the most part. But the shear here is not bad, so something that we're really going to want to watch for the most part. I'll actually move my my face cam back over here so that you guys can actually see. Cape numbers aren't really all too great. Lapses aren't either, so that's something to monitor there. Next sounding here is in central and eastern Texas. And this one follows the same path here. You know, good outflow, storm motion, right moving actually follows pretty well. So I don't anticipate this to be all too high precipitation based. Either of these cells here in the prefrontal convection for the most part in the beginning of the day. As I said, cyclic type hodograph. Your CAPE actually gets up into the 2,000 joules per kilogram forecasted, so that's actually not that bad. Shear, as I said, is pretty good. Lapse rates lack a bit to be desired, but that's the type of event that you're going to get with prefrontal convection. This is here more towards the triple point. You can actually see indicated up here. That's where I found the sounding, so the triple point area. Just by looking at the hodograph, this screams high precipitation. You still have cyclic type cell here, but high precipitation for sure within this area. And it's definitely looking kind of bonkers for the most part. But yeah, this is definitely a bit of a high precipitation type cell. It's getting right within the 20 knot vicinity of the storm motion. This also could veer off a bit more if there was actually some tornadic structure to form. The mesocyclone could actually veer off a bit more to the left. So that's something to keep in mind as well. But we'll get into that a bit more into the live stream in regards to how we can predict these cells and where they're going to be moving. But based off of the soundings that I found here, definitely could be high precipitation based within that cell. A lot of capping inversion that's dealing with, so the limiting factor is in place. Low cloud level is relatively low, but the level of free convection is pretty high, so yeah, chances for tornadoes, is there, but it's not really too strong, if you know what I mean. But I will say this much, your lapses are pretty good, and so you still could get that large hail, especially with how dry the upper levels are here in the 850 to 700 millibar vicinity. So definitely something to watch out for with that. Alrighty, final sounding here. This is for the other prefrontal convection that is in Louisiana and Mississippi overnight. As I said, not going to really be using CAPE a whole lot for this, because if you get just these regular storms that can form off, you can get these quick little embedded rotations that form off. But you do have a little bit of CAPE here. It says a lot of capping inversion, but that's only because I took a wide variety sounding here. A box sounding, as most of you would know it as, but very large veering hodograph. And this is definitely something that is going to be pretty interesting for the most part. You could get these wide looping, if you were to have mesocyclones to develop, you can get these wide looping mesocyclones to actually form off of this, basically because of how strong the lower level wind shear is and how weak the upper level wind shear is. So this is definitely a sounding that is pretty concerning for the most part, but with the lack of energy, I could just expect some quick spin-ups after those type of mesocyclones loop. So something to really monitor with that. All right, here is the day 3 outlook here for Saturday. I'm going to move my face again so you guys can actually see what's happening here. So day 3 outlook here includes places like New Orleans, Atlanta, Montgomery, Mobile, Columbus. A lot of these areas here, including Columbia, South Carolina, into Wilmington, North Carolina. Charleston, Savannah is also not out of this risk, as well as Tallahassee. I'm actually really concerned about these areas here in the southern part of the risk. Well, it's actually kind of in the central parts of the risk, but southeastern Alabama, southwestern Georgia, western parts of Florida, that general vicinity actually could get the highest potential for tornadoes, in my opinion. You can also get a risk here in eastern Georgia and southern parts of South Carolina as well, but we'll get into that a bit more when we get into soundings and stuff like that. just by looking at the risks here, it's the day 3 outlook, so it doesn't give you like tornadoes, winds, hail risks, stuff like that. It gives you a general risk for the most part for severe weather, so 15% chance within the areas that I called out for that was in the slight risk. Places like Raleigh and Jackson, as well as Jacksonville, you guys could get a lower chance for severe weather. Most of that is expected to die off overnight if you're in Jacksonville, but some of these other areas, you can just get the lingering storms that'll be moving through your area. All right, let's take a look at the reflectivity, or the simulated reflectivity. The thing about it is with this is that the NAM 3K, as high resolution as it is, it doesn't go out all too far. So we're gonna kind of conjoin it with its lower resolution twin called the NAM, and the NAM 12K, and we're going to basically tag team based off of that and see what all could be happening within this day. So you can see here's the band of storms that we were talking about before towards the end of the day 2 outlook on Friday into Saturday. So Saturday morning here, this line continues to move on through. You also have the leftover of the QLCS that was moving off through Oklahoma into Texas. So as that continues to move on through, you can see the line really starts to consolidate, but you also have a developing line that could be forming out in front of this line. And this is definitely something that we're going to have to watch as this continues to stir on through. But you can already see how this the former line starts to dissipate as we get in towards the noon hours. New line begins to develop, and then the funny thing about it is that that's when the NAM 3K actually ends, but then the old line actually begins to kind of develop a bit more. And so that actually could produce some more cells within that general vicinity. So you can have 2 waves here that could be pushing on through, especially if you're in southern parts of Georgia and western parts of Florida. So Tallahassee definitely could see more than just one round of severe weather, but 1 line, 2 line, and then as we continue to play this through, you can see the old line starts to begin to kind of dissipate towards places like South Carolina and Georgia, but then this new line begins to develop and really push on through here into Georgia and South Carolina towards the overnight hours, and definitely something that we're going to really want to watch as this pushes on through. But for the most part, after this event, after those lines really fire off, they begin to dissipate as you get into the morning hours on Sunday. Dew points! Fun times here because the NAM and the NAM 3K actually both agree in regards to the amount of moisture here in the general vicinity. And we'll see that here, the Cape numbers, but you can see these yellows indicate 60s, 70s in these darker yellows into oranges, and a lot of moisture here for the most part. This is actually the NAM 3K's convective available potential energy, or Cape numbers. So, you know, the buoyancy in the atmosphere, more Cape, the stronger the storms typically are. So 2,000 joules per kilogram is typically what you want to look for. Anything above that, pretty strong. Anything below that, it's kind of strong. You can consider strong supercells, but it's not really like it's not really as high of a chance as like 2,000 or even 3,000 for that note. So there is 3,000 joules per kilogram for the most part here in Louisiana and Mississippi. You also have 2,000 to almost 3,000 joules per kilogram here, just in this general area of this yellow. A lot of energy here for the most part. And so this is definitely something we're going to want to watch out for as this continues to move on through. Tomorrow's video, we're most likely going to have the NAM 3K to actually see far out within this event, so we'll be able to see what the NAM 3K and even the HRRR say about this event. Which, by the way, I'm not using the HRRR in my video today. For the people who actually know what the HRRR is, I'm not using it because I actually don't think it represents the dry line as well as it should, especially around the triple point. So, that's the reason why I'm using the NAM 3K here. But yeah, let's go into wind shear here, and here's the NAM 3K's version of wind shear, and it's really aggressive for the most part. you'll find out that most of these models actually tend to be really aggressive for the most part. But here's the lower level shear, the 850 millibar low level jet. You can see it gets pretty intense over areas near Alabama and Georgia, and even in that new line that or the old line that forms, you still have a pretty intense low level jet there in Florida. So pretty interesting to say the least. I'll create an arrow here, which indicates where this low level jet is going. Boom. All right, so we created our low level jet arrow, and then we'll go to our upper level jet, which doesn't have as much veering. That's one thing I did want to mention here with this. But the areas of veering that still show for the most part, it's here in eastern Georgia and southern parts of South Carolina. There's definitely some veering here. And so I am watching that area pretty closely. But I'm also watching this area right here. And you'll see why here in a second with the amount of veering here at the lower levels of the atmosphere. And there's actually another level called the 952 millibar streak. So a lot of veering within that as well. And you'll actually see that here in the sounding that I'm about to pull up. This is the NAM 3K here in southeastern Alabama, southwestern Georgia, and western Florida. Your hodograph veers. I mean, this thing just goes skirt and goes all the way around. And this is a very, very loopy hodograph for the most part. This also tells me that it could be a bit more long-lived, if you will. So it could long-live more under one mesocyclone. It could be a bit more cyclic, but it definitely could be a bit more long-lived as well. It's also pretty loopy, so you can have these large loops again here within the mesocyclone. It could actually veer a bit more to the left. Well, not exactly veer a bit more to the left, but it it kind of like swings down. So if you can imagine your supercell here, what actually happens is as the supercell begins to consolidate, the hook will actually loop a bit more, so you'll have your ball, but then within the next frame, it'll be something like this. And it'll just kind of like dig more inwards. And so it'll just kind of be like, whoop. Something like that. There you go. So if you can imagine like El Reno as to how it looped out like that, it's kind of similar to what I'm seeing here with the sounding. So a very strong wind profile, decent cape for the most part, no limiting factors. Lapse rates are pretty good for the most part, for Dixie, I should say. So this is a good sounding here, but this is from the NAM 3K. And I want to show you guys what the NAM says, which actually, if you look at it at face value, I'm about to switch it here, so, you know, just envision this real quickly. Vision this sounding. And I'll actually switch it back over here. Cape is not bad, as I said. I kind of blocked the thing, so I'm sorry. Lapse rates are pretty good for the most part, so yeah. If you can imagine this real quickly. This sounding. Not that different, quite honestly. You know, you still have loopy hodograph. It's a lot weaker, but you still have loopy hodograph. Still have decent cape numbers. Still have decent lapse rate numbers. So it's, you know, the NAM and the NAM 3K are actually, you know, representing practically the same thing. Your LFC and your LCL is practically the same within the same area. So the lower it is to the ground, the higher chance for tornadoes to spawn, or higher chance, higher likelihood, with other given parameters, mind you. But definitely something that helps out with mesocyclones, I'll say that much. Here's another sounding here for central to eastern parts of Georgia and to southern South Carolina. This is why I said there's a lot of veering here. Very, very, large extended hodograph. A lot of stream-wise vorticity here from 0 to 1 kilometer, but then in the 1 to 2 kilometer frame, there really isn't as much. So yeah, a lot of crosswise vorticity here for the most part here um, within this. And so this is definitely something we're going to have to continue to watch as this moves on through. As I said, probably not going to be like a mothership type, day with pictures and storm spotting. Areas near 1 to 2 kilometer and even 3 kilometer and 4 kilometer, all the way up to 6 kilometer, shows a lot of I keep forgetting the word, my goodness. Crosswise vorticity. Boom. Sorry for the anime picture there. Even I need to have notes and sit around. I honestly need to stick sticky notes around for the most part so that I actually know what most of the stuff is without forgetting it. I really need to start remembering it though, because I just studied it yesterday, but oh well. But yeah, a lot of streamwise vorticity with this. Kind of some decent energy. Cape doesn't really get all that high within that area, as well as your limiting factor is a little bit there, but that could create some explosive supercells. So we'll have to watch that closely. Here's southern Georgia, western Florida. That same veering here later on in the day. This is actually towards the overnight hours, around 7 Central, 8 Eastern. Still have energy, still have decent lapse rates, still have decent veering for the most part. And it doesn't look like it's going to be high precipitation based off of my knowledge here. So for the most part, it's going to be pretty good. You still have some good outflow as this supercell does exhaust most of its rain off, in front of the storm, not like inside of it. So that's good there. All right, part 2, severe weather outbreak number 2. Yeah, I know I've been just rambling for the most part in this video, but you know what? I've just been pretty excited with dissecting photographs for the most part over the past couple of days. So, that's just me saying based off of what structurally it will look like and what it could possibly do based off of that. But this is the part where it's going to start to get pretty unpredictable because number 1, we're 6 days out. This is the day 6 outlook. And, the one thing about it is that it's a tale of two models. The 2 long-range models that we have are saying within the same area there could be some severe weather, but the risks are somewhat different or either localized differently. And I'll show you guys what I mean by that here in a second, but for the Storm Prediction Center, 15% chance for severe weather has been issued for places like Wichita all the way down to Oklahoma City, Tulsa, all the way down towards Abilene, just to the east of Fort Stockton and Midland. So definitely something to keep in mind with that. Dallas-Fort Worth, you guys are not out of that as well. So you guys could be getting some severe weather on Tuesday. And so you guys are really going to have to watch this for the most part. The Euro model still shows what we saw yesterday. If we move on through, this is the evening, 7 o'clock Central Daylight Time. Discrete cells start to form. Iowa, Nebraska, Kansas, Missouri, Arkansas, down to maybe even Louisiana, Texas, Oklahoma. Also some areas here in Wisconsin and Illinois. I've been mentioning that I mentioned that in yesterday's video. You also have more discrete cells that form down here. And look at this. This just explodes. Boom. Line of cells that develop with this system. This is a very concerning setup here, according to the Euro. And it just continues all the way throughout into, just other areas like eastern Oklahoma into the morning. And the trough doesn't really move all too far. That's the thing. Like, this area gets severe weather one day. The next day, it's this area that gets severe weather. The next area, it's this area that gets severe weather. You know what I mean? Like, don't take those circles, exactly, with pinpoint accuracy and treat them as, like, absolute truth. These models can still falter. As a matter of fact, you'll see in a second as to the reason why there's a lot of uncertainty here with this event still in regards to placement. But what I mean here is that this cold front is going to be moving off very slowly, and we can get more and more supercells that could be moving off very slowly. And that usually isn't exactly, the best case scenario for all of us because, it's a more widespread area that can get severe weather rather than just, it moving by relatively quickly. So something to monitor with that. We're going to take a look at this from the GFS's perspective here first. So the GFS paints a picture of dew points here for the most part within the 70s, here the deep south into the Texas vicinity. 60s reach all the way up into Wisconsin and Minnesota. 50s in areas near Kansas, Nebraska, Iowa, and Missouri. But very moist for the most part here within this area. Lower level jet, this is when things get pretty interesting in regards to, placement. So I mentioned before that the GFS typically gets pretty aggressive. Well, I mentioned yesterday's video that the Euro is pretty aggressive. The roles have been reversed. The GFS is now turned really aggressive. And, just by looking at it, here's the low-level jet. I'll actually draw it out a bit for us so we can see the crossovers here. And the GFS actually paints the picture of this event being really localized in specific areas. And we'll see here in a second what I'm talking about. I'll add these arrows up here because I did say I would include them. There we go. And now we're going to move on to our mid-level jet, 500 millibars. And you can see, based off of these arrows, a lot of these go in the same area, except for down here in the south. This is when things get pretty interesting. And some of these areas here in Missouri and stuff like that, they also get some pretty interesting veering here for the most part. So, the risk for tornadoes is possible, but in regards to the timing with the GFS, it seems to be a bit more further out of the front, more into this general vicinity rather than back here where the Storm Prediction Center has it. But the reason why the Storm Prediction Center has it that far back is because if we take a look at the Euro, it's a different picture. It goes a bit further west, does it not? You have your triple point here with your warm front that advects a lot of warm moisture up into places like Kansas, Nebraska, Iowa, into Wisconsin and Illinois, Missouri, Arkansas, 70s for the most part here in the deep south into Texas. A lot of moisture here for the most part. And this is one thing, this is the reason why it's pretty concerning, because the Euro actually paints the picture of a high risk that was in 2019. Now, this busted significantly because of some factors that had to include a lot of the Mexican smoke that was advecting from Mexico. And so it was actually limiting a lot of the activity there based off of not as much significant moisture reaching, as well as the low-level jet being off target by a couple of hours. The thing of it is that the Euro doesn't have that smoke, and it has that low-level jet being relatively significant. So we'll draw this picture again here. We'll use blue arrows this time. So here's the low-level jet. You can see how it stays relatively north-south for the most part in Oklahoma and Texas, which is the thing that's concerning to me. And you'll see why here in a second. We won't include areas like Arkansas and Louisiana because we'll just assume they're the same. Here's the 500 millibar jet. And, yeah, that is a lot of veering. That is some pretty significant veering here for the most part. So that shows a lot of instances for it to be tornadic here, according to the Euro. So one model paints a picture of localized but strong, localized but a more stronger tornado threat because of how strong the 500 millibar shear is with the GFS. Another one paints the picture of a more widespread tornado event here in Texas into Oklahoma. But we can't say tornadoes yet because we don't really know what the kinematics is. We know it could be tornadic. We know it could paint the picture of a severe weather event. But we don't really have a whole lot of kinematics yet, which is basically just your cape and stuff like that. Our wind shear isn't also as set in stone as a lot of people think it is. As I said, one area has it a bit further west, one area has a bit further east. And so, until we can pinpoint exactly which area is which area is going to get stuff, and how the GFS and the Euro, if they start to trend a bit more towards each other, until that happens, we don't know exactly where this is going to happen. But this shows some really interesting setups for the most part here within this event. So we'll talk about that a lot more as we get closer and closer, and we'll get a lot more information as we get closer and closer. I'm really curious to see what the photographs will show in regards to what type of an event it will be, because, as I said, I've been studying photographs for the past couple of days, and I actually I've done a lot of studying. A lot of people on YouTube actually have some pretty interesting videos on how to read photographs and how that can actually translate towards the surface and how storms actually function. So a lot of people think that, some of these storms in regards to, how unpredictable it can be, how unpredictable mesocyclones can be. These people have actually narrowed it down to where the mesocyclones could actually go, and the specific character traits of supercells. So that's pretty interesting there for the most part, and that's what I was studying over the past couple of days. So you saw a little bit of that in my video today, and yeah, that's what I plan to try and carry out for you all in my forecast. So thank you guys so much for watching. I have timestamps in the video. I probably should have, said that in the beginning of the video, but I did want to just get out of the way that I said I was going to be live streaming. But if you guys did like the video, please be sure to leave a like. Subscribe if you're new and turn on notifications. Share this with friends and family. I do analysis like this, as I said, every video. I also live stream the event live. On Friday, we are going to have our chaser, by the way. If you guys stuck around towards the end, Matt will be chasing and he will be giving us footage. So if you guys are excited for that, feel free to also stay tuned, turn on notifications. Also follow me on my social medias down in the description down below. That's going to be it from me. My name is Nate. I'll go by Hockey Boy Nate. I'll catch you guys tomorrow. Peace.